All right. Again, this is the second video talking about slope. So we're going to talk about a couple of special slopes, and then we'll talk about the applications of slopes as well, a few different ways to use our slope formula. So first of all, let's remember what our slope formula was, right? Let's go ahead and write that down. If we're talking about slope, we typically call it m, right? And we're going to call that y2 minus y1. Do you remember why the y's are on top? When we're talking about slope, remember we always say rise over run. And remember that on our graph, the rise, right, up and down is always our y coordinate, right? It's our y axis. So we're talking about that y coordinate, the y measurement, up and down along that y axis. Though the y's are the rise, the x's on the other hand, so x2 minus x1. Remember those 2's denoting they're coming from the same coordinate. The one, this little sub 1's just saying they're coming from the same coordinate. And again, we're just subtracting because we want the difference between, right? The difference between the rise, the vertical measurement, in ratio with, right, divided by the run, the difference in x coordinates. Let's try that with the points down here and see how they're a little different than some of the examples we've done before. So again, I'm going to say m equals, let's take our y coordinates. So note they're both 2's here. So 2 minus 2 divided by our x coordinates. So I'm going to start with this 3, because again, 2 and 3 came from the same coordinate, minus, and again, the negative 1. Now, if you did it in the other order, that's okay. But again, 3 minus negative 1 is going to be 3 plus 1. And basically, we're going to end up with 2 minus 2 is 0 over 3 plus 1 is 4. And if you remember, 0 divided by anything is always equal to 0. As long as 0 is on the top of our fraction, we're equal to 0. Now, why would that happen? Well, if we plot both of these points, notice I go negative 1 unit and then up 2 units, and then positive 3 units to the right and up 2 units, and we plot those 2 points, right? We're going to be right along this red line here, plotting those points, right? And I notice I forgot my arrows again, just reminding us, any line's going to have arrows on both ends here if we're going infinitely left and right. But from those 2 points, if I draw that line infinitely through those, notice what kind of line that is. Again, it's not a rising line, which would have been a positive slope. It's not a falling line, which would have been a negative slope. This is actually just a nice straight horizontal line. Horizontal lines always have a slope of 0, right? We're not going uphill, we're not going downhill. Our slope is just 0. It's just flat, right? Flat line, basically, like straight left and right, like flat ground. Well, let's try these 2 points over here at the right. Same idea, m equals, so again, we're going to take our y coordinates, so negative 1 minus a negative 3, which means I can call that plus 3, right? Negative 1 minus negative. Minus the negative becomes plus. And then on the bottom, since negative 1 came first, I'll put this 4 in here first. Minus, well, negative 3 also had a 4 that was attached, right? So there we go. So negative 1 plus 3 is going to be 2 over 4 minus 4 is 0. Now that's a slight problem. Remember that 0 on the top, like it was in the first example, just gives you back 0. But 0 on the bottom, well, we can never divide by 0. So we call this undefined, right? Undefined. Now that might be kind of confusing because, hey, if we plot 2 points, I can plot the point 4, negative 3, right? Right about here. And 4, negative 1, right about there. Well, I can definitely draw a line through those, right? I can definitely draw a line straight up and down. But the problem is, remember, we're not saying that there isn't a line. We're just saying that the slope of that line is undefined. 0 is horizontal, positive slopes rise, negative slopes fall. But what do we do about a line that goes straight up and down, right? Straight up and down, infinitely upwards and infinitely downwards. Notice we get those arrows on there, right? Well, that doesn't really have slope. The ratio of rise, which is infinite right now, right? We can go straight up and down. Over run, well, we never went left or right. So the slope right there, we just say is undefined. So what we want to realize is any vertical line, right? Any line like we just drew, a vertical line straight up and down, no movement to the left or right, just straight up and down. Any vertical line is always going to be an undefined slope. Again, it's not that the line doesn't exist, it's that the slope is undefined. So again, 2 special slopes for you there. Zero slope means a horizontal line. Undefined slope means a vertical line. Let's take a little look at application in the real world here. One other way to talk about slope is to talk about it as a rate of change. Now that makes sense because we're changing the y coordinates, right? If we had a couple of coordinates here. So let's say we're parachuting. We started off 2,500 feet in the air. So we'll call that times 0, right? We're 2,500 feet in the air. And then they tell us after 35 seconds, now we're 2,115 feet in the air. Well, we're definitely falling. So what type of slope would you expect to have? I hope you said or thought negative slope. Again, we're going downwards from left to right. We're going to go downwards here. So what is your rate of change? Well, the rate of change is the ratio of the change vertically and the change horizontally. So we're going to fall, right, 2,500 feet down to 2,115 over the course of 35 seconds, right? Rise over run, basically subtracting those coordinates, right? 2,115 minus 2,500, 35 minus 0. Do a little division there, and it turns out that our slope is negative 11. Right? Now, what is that slope actually saying, right? What is that slope actually saying? Well, we're saying we're falling 11 feet per every 1 second, right? We went down 385 feet over 35 seconds, but over the course of every 1 second, right, from left to right, if we just went 1 unit right, we're technically going down 11, right? Down 11, right 1, down 11, right 1, down 11, right 1. And that would keep us right on our line. Assuming your rate stays about constant, when will you reach the ground? Well, we need to go down another 2115. And this is a perfect time to remember that slope is a ratio. That negative 11 is really negative 11 over 1. Negative 11 feet for every 1 second. So we can set ourselves up with a nice proportion. Negative 11 feet to every 1 second. I need to go down another 2,115 feet, right? 2,115 feet over the course of how many seconds? And very simply, it's a great chance to cross multiply. We'll take negative 11 times x and 1 times negative 2115, divide by negative 11 here, right? Divide by negative 11 on both sides, and we'll basically figure out that's going to take about 192 seconds, a little bit over that, 192.273, accurate to 3 decimal places. If you have to round at all, let's round to 3 decimal places. All right, 1, 2, 3 is good enough for us. Round to 3 decimal places. So that's a pretty easy way to use the rate of change or the slope. Let's do one last example here. So again, if we're not talking about rate of change, what if we're talking about the fact that we're not missing the slope? What if we know the slope between 2 points, but we're missing one of the coordinates? We want to know when something's going to happen. Find the value of y so that the line passing through the points has a slope of 2. Well, very simply, what I'm going to do is set up my slope formula. I know that m equals y2 minus y1 over x2 minus x1. So let's plug in what we know. y2, I'm actually going to use as my first coordinate here. Let's make this one right here. So I'm going to say y minus 8 over, and then on the bottom, again, if I used y first, I need to use that 3 first. If I used 8 second, I need to use the 5 second. And again, I'm always subtracting, right? The difference between the y's divided by the difference between the x's. Rise over run, y minus y over x minus x. And I know that my formula should equal m. Well, I know that m for us is 2. So I'm going to clean this up just a little bit. 3 minus 5 on the bottom, right? I can do that without too much work, is negative 2. Now, if you want to think of that as over 1 and cross multiply, or if you just want to multiply both sides by a negative 2 right now, that wouldn't be a bad idea, because again, on the left side here, that's going to allow us to cancel, right, those negative 2's. So y minus 8 will equal 2 minus or times negative 2, not minus, times, right? 2 times negative 2 is going to be negative 4. And then finally, I'm kind of running out of room here, so I'm going to move up here. Again, I'm going to take my equation. I'm trying to get y by itself. So let's go ahead and add 8 to both sides, right? Y equals negative 4 plus 8 is 4. And my guess is if we actually plotted these points, right? If we plotted 5, and I'm just going to approximate a little bit, 5, 8, right? Here's 5, up 8. And I plot the point 3, negative 4, right? oops, sorry, positive 4, 3, 4, about halfway up to 8, right? This would have been 8. Well, here's 4. 3 is going to be right about here. Doesn't that look like we could have been a slope of 2? Definitely rising. So again, I would agree that if y were 4, this problem will be true. I hope that helps you with some unique examples of slope. Again, if you have any questions, talk to your teacher. Otherwise, have a great day.